Well, Mauricio, you got a lot of things on the board here. I see it's going to be something about InfoScale Access. This is obviously the architecture. What can you tell us about this?
Yeah, it is not so difficult as it seems. Let's start from the bottom part. As you can see, the InfoScale Access is based on InfoScale CFS-HA. So we have the module that manages the storage, so multipathing, and all the other features that are related to the storage. Then some modules that you already know, the cluster volume manager, FSS, modules that manages FSS, Smart I/O, VCS, because this is an InfoScale cluster with an InfoScale Enterprise, basically. On top of it, we have the cluster file system that provides the shares that will be that shares the volume to the upper levels. Then we have the NAS storage. The NAS storage is the module where the shares are created. We will create shares, we will provide the multi-protocol access to the shares, and we will manage the top premium features that InfoScale Enterprise offers to InfoScale Access. The duplication, snapshot, replication, encryption, and once again, they are provided natively and locally in InfoScale Access cluster. On top of the NAS storage, we have the cluster management backend. The cluster management backend is made of some services that are interacting each other. This is mainly the part where the requests that come from the users are managed. One of the two interfaces in InfoScale Access is the command line, the CLISH. So we have a module that manages the CLISH. And a small part of the requests that come through the CLISH are directly sent to the bash shell and directly processed by bash shell. However, since bash shell is not top performing, it is not safe, it is not stable, most of the requests instead are converted using a CLISH XML configuration file, and they are converted in Python and sent to PySNAS. PySNAS is an interpreter. It executes everything. It is written in Python. Python is more stable than the bash shell. It is faster, better performances. So we will use more Python SNAS than the bash shell. On top of the cluster management backend, we have VOM. And now you know that VOM uses a specific daemon, a specific service, XPRTLD, to communicate with the managed hosts. Now, in InfoScale Access, the nodes in InfoScale Access are the managed hosts for VOM. So we will have this module that will let VOM communicate and manage with the user interface, with the graphical user interface, the rest of the InfoScale Access cluster. In VOM, we have the multi-cluster orchestration framework. This is the same orchestration framework that VOM already has natively, but there is a specific add-on that we will add in VOM. It is called Access Insight. It is made approximately for InfoScale Access that will add more features, more frames, masks, functionality, reports, role-based access control for InfoScale Access, discovery of the modules, notification, and many other features that will be managed directly in VOM. Of course, the user will connect to VOM using the management console. And this is the web server that is already in VOM, so that you, from your Internet Explorer or Firefox or whatever, you will be able to connect to the management orchestration framework in VOM and to manage completely all the InfoScale Access structure.
OK. So really, customers would be able to use VOM to do the communication and the setup of InfoScale Access. Is that
exactly
the summary?
Exactly. This is the best console that can be used to manage InfoScale Access.
OK, fantastic. Well, I think this gives us an idea as to how InfoScale Access is set up. So, Mauricio, thank you so much for taking us through it.
It's a pleasure.